let's do a quick sequence of operation. Now there's a lot of logic built into this circuit board. First off, you turn the machine on. What it's going to do is the circuit board, like I said, has logic built into it, but it's going to energize a fill valve. It's going to fill this guy with water. It's looking for this water float to get to a certain level. Once it gets to a certain level, it sends a signal to the board, and then there's some logic, a timer built into it. Once that finishes or completes, then it's going to turn itself into a harvest. It always starts in a harvest. And the harvest, this hot gas valve right here, is going to put hot refrigerant, okay, hot gas, right into the suction line, okay. After the expansion valves, it's going to warm up the evaporator and melt off any potential leftover residual ice, okay? We've got a thermistor right here that's running to the outlet of one of the evaporators, and it's looking for a certain temperature. After a timed function, once that thermistor reaches a certain temperature, a timer starts in the board, and once that's over, it starts the freeze cycle. When the freeze cycle starts, the water pump turns on, okay, starts running water over the evaporator, the hot gas valve turns off, the compressor continues to run, and the machine runs for a certain period of time, okay? After some logic in the board, there's a timer in here. After that timer completes, the board starts to look for this water float again to drop, okay? Because it works off of the principle of it puts a certain amount of water at the beginning of the cycle, and at the end of the cycle, that water should be at a certain level because it's become ice cubes. So once, after a certain timer function inside the board, this drops down, then it thinks that the machine is full of ice. It initiates a harvest cycle and then starts over. There's also a pump out feature built into the end of the harvest cycle. I can't remember if it happens every time or periodically, where it'll actually pump out all the water from in the sump. That's the plain, simplest explanation of how this machine works. There's also some sort of a bin control. This one is a mechanical control. It uses an electronic signal. When this flapper gets closed, it assumes that ice is backed up. There's also an older style machine that uses a thermostatic control that basically is a temperature controller. And when the ice gets so close to it, it says, hey, I'm full of ice, shut off. Because if they didn't shut it off, then the machine would freeze up, okay? These machines are very critical that they have the right flow rate of fresh inlet water coming in. As far as when it goes into a freeze cycle and then it determines that it's full of ice and it harvests the ice off, it uses in conjunction the hot gas, which it's using right now, okay, and it uses fresh water coming in to help break the vacuum on the ice cubes to make them fall off. If you don't have adequate fresh water supply, then that leads to freeze up issues. The other thing that leads to freeze up issues is a potential bad bin control or bad bin thermostat, okay? Most common issue with freeze up is bin control, and then in my experience, second most common is bad water flow coming into the machine, fresh water. That could be caused by a plugged up screen on the water inlet valve right here, or it can be caused by plugged up water filters or just low water pressure in general. Freeze ups, a lot of freeze ups over time can deform the evaporator and cause it to break, be completely, bad, and you have to replace the whole evaporator. So freeze ups are a big issue with the Hoshizakis.
This video is brought to you by Sporlan, quality, integrity, and tradition.
A couple of ice machines that are giving us a problem, so we're going to turn them on, and the customer had them off. We'll see what's going on here. So the customer had shut these off. My question to them was, because they said they had to reset it, was did they have to push the reset button on the board, and they didn't even know where the board was, so no. Still don't know what the problem is, but that tells me that it's not like a lockout situation. So the left machine filled, and then the water pump turned on. That tells you a lot. The same thing about the right machine. Okay, so we got to figure out, because they said it was beeping though, so interesting. I'm noticing what looks to be like a lot of air in the pump. And let's see this one. See, this one's not doing it. Huh. Interesting. So we come over here to the drain, and look how the drain is leaking water. That's not good. If I trace that back, that'll end up being a machine drain for one of them, I bet, because there's no water in the bin. The bin's completely empty. That would indicate a pump out valve check valve leaking by. So I'm just letting the machines run their course, even though I already have a feeling this one's leaking at the pump out valve probably. Eventually what will happen is the machine will run out of water. Oh, see, it stopped though. So that's interesting. Huh. But still, it was leaking back for too long. So that's something we need to look into. Okay, so this one harvested prematurely, and we've got really thin ice cubes coming out right now. It's only been running for 10 minutes. Oh, looks like they've been buying ice. But yeah, so this one is probably the one with the water valve leaking by then, because well, we'll see. But basically, the water flow looks at the water level in the sump, and if the water level's low, it assumes that it's got a full batch of ice. Okay. This one just harvested too, so both of them are harvesting too early, so left and right. Okay, we're gonna shut them off and pull these pump out valves apart and look into those, and also look into the water flows. All right, so there's some sediment in there. Let's see what's on the back side of this. Oh, check it out. We have a cube guide piece. It's that little piece from the cube guide. It's busted off, and that's causing the pump out spring to get stuck. Or check valve, you should say, pump out check valve. This basically lets the machine purge water to drain, to purge any sediment in the bottom, basically. So you can see several pieces missing. Where those are, I don't know. They could be anywhere in the machine. They also get stuck in the water pump. So if you ever find these, you need to break off all the pieces that you can, that way they don't get stuck, and then we'll have to order a new cube guide for this left machine. So I'm looking for anything that has potential to crack or break, and you'll see like micro cracks. So you gotta break the little pieces off, because they'll break off later and get stuck throughout the thing. Now this is just a temporary fix until we can get, those are all the pieces that I found cracked. So this whole cube guide's just destroyed, and I imagine this other one will be the same too. I pulled the pump out, inspected the inside and the impeller to make sure that there was no other pieces stuck in it. We need to look in the sump too, because there should be more pieces floating around in this thing. This is not a black hose, that's clear. So we need to go ahead and replace that hose. It's got nastiness built up. You can brush it, but you'll never get it to change the colors. Now this is a black hose. People ask why they do clear. It's because you'll never see that they're dirty. See, on the black, you can't see what the inside looks like. Also went ahead and pulled the spray rails out of the top, and investigating to see if there's any of the cube guides stuck in there. No. The machine needs a quick cleaning though, but we're definitely going to get them a list of things that we need to change. We still don't know exactly what's wrong with it, but we're going to keep going with it. I went ahead and ran a brush. I got these long fitting brushes. This one's from Granger's. There's the part number for everybody that's going to ask. It didn't even take any of this stuff off. Nothing even comes out. They just get stained over time. So we're going to put the machine back together, and then we're going to run some ice machine cleaner through it, and then see if the small cube thing stops. Maybe adjust the float if necessary too. It was a little dirty. Okay, the machine is all back together, and I put it on the ice mode so that way it would fill up with water. We're just using the fill cycle. Once it's full of water, I'll pour some cleaner in there and turn it to circulate mode. Always got to make sure those cube guides are down all the way. We'll turn it to circulate mode and let it run with ice machine cleaner, and then we'll disassemble this machine and see what's going on with that one. You know the sump is full on water when it starts to come out the overflow. It always overflows to do like a siphon to pull the crap from the bottom of the sump. So once it starts overflowing there, then we'll put it into wash mode. Pulled the pump out, didn't find any pieces on the right machine. Pulled the check valve, and look at that. So these things cause havoc. You've got to change the cube guides. These, you know, $60, $70 parts cause a lot of hell. So we're going to finish checking the machine out, seeing if we find any more pieces, and we're also going to pull this cube guide out. The same thing as the other one, it's got broken pieces, so we'll find any more broken ones and break them off. These things are sneaky, man. Pieces, they're sometimes difficult. Oh, by the way, I had them empty out the bin, so that way I could run ice machine cleaner through it. But I saw another one here just a second ago. Where's it at? Right here. Right here, it's cracked. Look at that. See, they're sneaky. It's hard to see them, but you got to get them all broken off. This will just slow down the potential for these things getting stuck, because they're going to continue to break. It's typically, in my understanding, from the chlorine that's put in the water. Double check the spray rail, nothing in this one either. So we'll put this one back together and run some cleaner through it. I didn't see any pieces in the sump, so. All right, I did a couple fill cycles, filled it up, let it overflow the drain over and over and over again to flush out all the ice machine cleaner. And then once we were done with that, I'm draining all the water out. We're gonna fill it up with clean water, and then we're gonna run sanitizer through each machine, sanitize all the surfaces we've touched, and then we'll turn it on and finish troubleshooting. Okay, both machines are now getting ready to make ice. They're currently in the startup harvest. They start up to purge the machine of any ice potentially left on the evaporators. They always start in a harvest. So when that's done, when it goes into the freeze cycle, we're gonna start a timer, and we're gonna time how long it takes for both of them to make ice. Ice machines take a while, especially the Hoshizakis, to make ice. But while I'm waiting, just came up onto the roof, inspect the condensers, make sure there's no big issues. Condenser fan motors are running, I can see right through them, so don't see any issues there. Well, I don't even have my service gauges on this yet, but you notice 16 minutes in, we're starting to frost up. We've got a water drip coming from here too, causing some frost buildup, but that's another thing. But you come over here, this compressor's nice and warm to the body. Come over here, this whole compressor's about to start frosting, and we don't have frost accumulation on our refrigeration lines. Now, without having service gauges on here, I'm gonna tell you, because the pump is running, and it seems to be running properly, that more than likely we have a TXV that's flooding. We'll have to do some more checks, obviously. I'm gonna let this cycle finish out and see what it does. So on the right machine, they both started about the same time, 23 minutes. You can clearly see that there's ice up in there. And on the left machine, same thing. There's no ice whatsoever, and my compressor is, yeah, so we've got a TXV that's flooding. Something stuck in it or something like that. But like I said, we're gonna let it finish out the cycle, and then we'll gauge up on it and compare the two systems and show you the different pressures. All right, the right machine made ice 27 minutes, and then the harvest was 4 minutes for a total cycle time of 31:46. Now we could use that to do a production check too. We might do that in a little while, but this guy doesn't even have ice present at all. The whole compressor is actually starting to get frosty. We're gonna turn it off. We're gonna put pressure probes on it. We'll go ahead and stop this. Put pressure probes and compare the two. All right, I went ahead and drained the sumps of both of them so they're equally starting up. They're both turned back on. They're gonna go through the fill cycle. Then when the water pumps turn on, we'll start timing them. Got the Hoshizaki Tech Specs book right here. Turn to the model number of the machine, KM901MRH. We have approximately 70 degree water. We have approximately, we're above 70 degrees ambient, but we're below 80, so we're gonna use the 80 degree ambient. So approximately at the 5 minutes in the freeze cycle, we should have a 40 suction and a 249 head. So I've got that written down. This also has the times and everything else written on it. You can get these books directly from Hoshizaki. You can also download them and print them out. So we've got everything written down. As soon as we get started at the 5 minute mark, we'll record those pressures. Both machines are now in the freeze cycle. They have been for 20 seconds. When they get to the 5 minute mark, we're gonna write down all of our numbers, and I have it broken down right here, and we'll compare the left side to the right side. So we've got suction line pressure, liquid line pressure, and suction line temp after they merge together, leaving the evaporator. Now I realize more than likely it's just one TXV that's bad, but you change them as a set. So we're getting a common suction line temp coming out of both evaporators, and we'll compare that and see how they operate. I'll also get an image with the thermal imager showing you the compressor too. All right, we're coming up on the 5 minute mark now, so we're gonna start writing down these numbers, and then we'll compare them to what they should be. All right, got the pressures written down. So the left machine is 73 PSI on the low side, 216 on the high side, with a 37 degree common suction line going back to the compressor. The right side is 50 PSI on the low side, 256 on the high side, with a 26 degree common suction line going back. So you can see this one, we're getting the evaporator temperature lower, therefore we can get it below freezing and start to build ice. On the left machine we can't. our evaporator temperature is above freezing and we're flooding refrigerant back to the compressor, liquid refrigerant at that, because it's not fully boiling off in the evaporator. So this is going to cause compressor issues. The problem would be the expansion valve, one of the two. There's two expansion valves on this guy. These are them right here. Now the first thing you want to check is you want to make sure that the sensing bulbs aren't loose or anything. You can usually do that by grabbing in here. So long as they haven't been changed, they're actually taped on. I don't feel anything loose. I can physically feel the sensing bulb. It's nice and tight. It's nice and tight. More than likely there's some sort of debris stuck in here. We've done repairs on this machine before. Actually, I've done repairs changing hot gas valves because I believe something was stuck in the hot gas valve, I think, or something. I don't know. You guys may remember. I don't. When you change these valves, you change them as a set, as per Hoshizaki. It's just smart move anyway. So, all right, that compressor is clearly pretty cold. That is the left side. Let's move over to the right side and look at the difference. 93 degrees, 97 degrees. So yeah, we got an issue. We're going to give them a big picture quote on this machine with all the issues. We're also going to talk about replacing some of this hose right here, new cube guide, and then we're going to do a thorough cleaning. I just did a quick cleaning today. So everything else is looking good. This one right here is making ice, so they're going to have this machine operating. This machine I'm going to shut down because we don't want to ruin the compressor. Let's do a quick sequence of operation. Now there's a lot of logic built into this circuit board. First off, you turn the machine on. What it's going to do is the circuit board, like I said, has logic built into it, but it's going to energize a fill valve. It's going to fill this guy with water. It's looking for this water float to get to a certain level. Once it gets to a certain level, it sends a signal to the board, and then there's some logic, a timer built into it. Once that finishes or completes, then it's going to turn itself into a harvest. It always starts in a harvest. And the harvest, this hot gas valve right here, is going to put hot refrigerant, okay, hot gas, right into the suction line, okay. After the expansion valves, it's going to warm up the evaporator and melt off any potential leftover residual ice, okay. We've got a thermistor right here that's running to the outlet of one of the evaporators, and it's looking for a certain temperature. After a timed function, once that thermistor reaches a certain temperature, a timer starts in the board, and once that's over, it starts the freeze cycle. When the freeze cycle starts, the water pump turns on, okay, starts running water over the evaporator, the hot gas valve turns off, the compressor continues to run, and the machine runs for a certain period of time, okay? After some logic in the board, there's a timer in here. After that timer completes, the board starts to look for this water float again to drop, okay? Because it works off of the principle of it puts a certain amount of water at the beginning of the cycle, and at the end of the cycle, that water should be at a certain level because it's become ice cubes. So once, after a certain timer function inside the board, this drops down, then it thinks that the machine is full of ice. It initiates a harvest cycle and then starts over. There's also a pump out feature built into the end of the harvest cycle. I can't remember if it happens every time or periodically, where it'll actually pump out all the water from in the sump. That's the plain, simplest explanation of how this machine works. There's also some sort of a bin control. This one is a mechanical control. It uses an electronic signal. When this flapper gets closed, it assumes that ice is backed up. There's also an older style machine that uses a thermostatic control that basically is a temperature controller, and when the ice gets so close to it, it says, hey, I'm full of ice, shut off. Because if they didn't shut it off, then the machine would freeze up, okay? These machines are very critical that they have the right flow rate of fresh inlet water coming in. As far as when it goes into a freeze cycle and then it determines that it's full of ice and it harvests the ice off, it uses in conjunction the hot gas, which it's using right now, okay, and it uses fresh water coming in to help break the vacuum on the ice cubes to make them fall off. If you don't have adequate fresh water supply, then that leads to freeze up issues. The other thing that leads to freeze up issues is a potential bad bin control or bad bin thermostat, okay? Most common issue with freeze up is bin control, and then in my experience, second most common is bad water flow coming into the machine, fresh water. That could be caused by a plugged up screen on the water inlet valve right here, or it can be caused by plugged up water filters or just low water pressure in general. Freeze-ups, a lot of freeze-ups over time can deform the evaporator and cause it to break, be completely, bad, and you have to replace the whole evaporator. So freeze-ups are a big issue with the Hoshizakis. All right, so left machine's down, right machine I got going. They also have another ice machine right here that's been down since before the whole COVID thing. Don't know what's wrong with it. I'm gonna try to get this one running so that way they at least have 2 ice machines. That's the hope at least. So we're gonna open this guy up and check it out. On the Manitowoc machines, you wanna watch the circuit board lights. So the machine's off, we're gonna turn it on and see what happens. And if anything flashes, you count it. Toggle switch right off the bat. It doesn't really push in very well, but it starts right up. So we're gonna watch it make ice and see what happens. All right, I haven't put service gauges on this, but this thing's just about to make ice. It looks like the thickness probe might be a little thick. We might just run a cleaning through this. The other thing is that if this machine ever shut off on a safety, it should still show that safety unless it's made ice so many times without making that same safety again. So the fact that there wasn't a safety limit kind of makes me wonder if they just shut this machine off because of COVID or something. I don't know. So this one we might just have to tell them to keep an eye on it. I'll probably run some cleaner through it just to be safe though. But yeah, that ice is a little thick, so I'm gonna thin up the thickness control and just run some cleaner through it. Well, this guy made ice in a reasonable amount of time, so we're gonna shut it off and we're gonna run some ice machine cleaner through it and just tell him to keep an eye on it. I don't see the need to put gauges on it. I don't see any active safety limits present, so we're just gonna tell him to keep an eye on it and we'll see if it gives him any other issues. I mainly just got some of the surface calcium off. This thing needs a deep clean, but this will be better for now. So I cleaned it with the ice machine cleaner, and then now I'm running sanitizer through it because it had a lot of slime buildup too. So I'm probably gonna go ahead and replace the thickness sensor and water level probes because they're pretty calcified and I don't want to be scraping on them. I actually had one of these things in my truck. Haven't worked on an S model machine in a long time, but hopefully it'll work. Alright, these older machines, 14 minutes was pretty much the max freeze time. So when you start hearing the evaporator pop, this ice is getting thick. On these old machines, you could actually set the thickness based off of the ice. You're supposed to use an 1/8 inch bridge, but you could actually do it with the ice in mind, and basically it's thick enough right now, so I'm gonna go ahead and make it harvest. So the harvest light's on now because the water coming off the top of the ice machine is grounding out that terminal, so it should go into harvest right now, and that's good. We should get a solid sheet falling off. All right, I'm gonna watch it make ice one more time because I adjusted the thickness a little bit thinner. But we had a 1 minute harvest cycle and a 10.50 minute freeze cycle. These are typically max 14 minute freeze. I think it was 3.5 minute harvest was the max. So this one's right within the money. I don't see the need to put service gauges on this one. I ended up having the thickness probe. These things, if you worked on these machines, you knew that right up here in the top right here, there was silicone, and that silicone on the inside, when they pressed it together, would wear away. So when you dip these in cleaner to really clean them, they would get all jacked up and cause premature harvest issues. So we used to change these things like candy all the time. I was surprised I actually had one. I haven't changed one in probably 8-9 years. I just happen to have it in my van still in the packaging. So we're gonna watch this make ice one more time, and we're gonna get out of here and give them a quote to fix this left side ice machine. A couple things on this one, and I think we're gonna still change the water level probe on this one right here, and then that'll give me an opportunity when I come back to make sure this one's still working.
All right, lots of ice machines down on this one, 3 total, okay? The first 2 ice machines were the Hoshizaki ice machines. The left ice machine had 2 problems, okay? Number 1, it had a flooding expansion valve, but number 2, the pump out check valve had a piece of the cube guide stuck in it, okay? So solved the cube guide problem, but then diagnosed the flooding expansion valve problem, so we shut that machine off. The second machine had pieces from the cube guide stuck in its pump out check valve too. Went ahead and removed those. The machine was operating. Okay, the third ice machine, the Manitowoc ice machine, I mean, I found a couple little things, but nothing really wrong. And the customer told me that machine had been down since like when COVID happened, first started or whatever. So like March or something when the lockdowns first started, I'm assuming. But I don't know what the actual problem was. Okay, so it's been down so long. I don't know, you know, and I went through it quickly and really didn't see anything wrong other than a few issues like the power switch was sticking, the thickness was a little thick, the machine itself was dirty. That was to be expected from being off and just sitting there with water in the sump. It was very important that I drained out all that nasty water and cleaned it with sanitizer too to get any potential bacteria or anything like that out of there. Always want to be careful about when you're working on these machines. As you're done cleaning or as you're done working on them, you really want to go through them with a sanitizer. As you're coming out of the machine, you clean with sanitizer, sanitizing everything that your hands touch and that kind of stuff. We need to be ultra careful when we're working on these ice machines because that's food. I mean, people are eating that, drinking that, and your hands, you know, are on your dirty tools and all that stuff. So you need to be very cautious about working in the ice machines. I'm not perfect either, but I try to do my best, okay? So this was like a triage situation where we had to go through and just try to do our best to figure out what was going on. Now, I will be 100% clear with the customer that the things that I'm going to quote, I am not guaranteeing those are going to solve all their problems. We need to start with those problems, fix those, clean the machines properly after that, then we can continue diagnosing. So they will completely understand when I am done quoting it that this is just to solve those problems at hand, and, you know, we need to make sure there's nothing else wrong. Now, the fact that I turned off the left machine, that one, there's nothing we can do about it. But the middle machine and the right ice machine, they should continue to run until I get there, okay? And if they don't, I will call them and follow up. If they're still having issues, then I'll go back out and diagnose further, okay? I really didn't see the need to put my gauges on the far right ice machine, but again, you know, I was looking at the circuit board, okay? The logic board basically tells me, you know, if there was a problem, it would record it on the logic board. Basically, if it took too long to make ice or took too long to harvest, it'll record it. And that record doesn't go away until it has so many consecutive cycles after not doing that problem. It has to do, like, I want to say like 100 cycles of, or 200 cycles or something like that, of ice, you know, ice making without having that issue again. Then it clears that out of the logic board. Okay, so the fact that it didn't have anything on there, you know, tells me that it might have just been a power issue or something like that. But at the same time, I don't know how that, like, it's been 8 months or 6 months or whatever where it's been off. So, you know, I don't know. It's kind of weird. But I wasn't going to spend all day on it. I reset it, did my best, got it operating, and just told the customer to keep an eye on it, okay? Same thing in the beginning of the video, I was kind of explaining with the Hoshizaki ice machines too. My first step was asking the customer, hey, what's going on with these? Hey, and, you know, and they said, oh yeah, we've had to reset it. And I say, okay, what do you mean by reset? Because reset to me and reset to them is two different things. Reset to me is they pulled the cover off the circuit board, they hit the button, it was beeping at them, and that reset it, okay? But to them, that wasn't the case. None of them knew where the circuit board was or where the reset button was. So, and I didn't tell them. I just said, okay, when you say reset, what do you mean reset? I said, did you flip the power switch off, or did you open the unit up and reset the reset button? You know, did you get to the circuit board and push the button? They're like, oh, what? I didn't even know there is. Okay, cool. That answered my question. They didn't reset a safety within the machine, okay? They must have just turned the power switch off or something, and they call that resetting it. And that kind of investigation really does tell you a lot, because, you know, if you just listen to the customer and they said they reset it, you could go down a path trying to find, you know, and there might not even be anything wrong. Okay, the next thing is if they did tell me, yeah, we reset the board, I would say, how many times was it beeping? Because on the Hoshizaki ice machines on the left, yeah, those ones have a cycle and they beep for every error message that there is a certain amount of time. So, you know, it doesn't necessarily mean that we're going to solve everything in those initial questions, but it's just the stuff that I go through, picking the customer's brain. And at the same time, I'm trying to BS with them and just have a general conversation, because it actually has been a while since I've seen this customer. We were kind of talking about COVID and all this stuff and how it's going. But that small talk really does get you more answers, because it just builds a good conversation with the customer, and they'll tend to be more open with you about issues or different things like that, versus if you just walk in with an attitude and say, okay, what's wrong? What happened? Did you do this? Did you do that? You know, just start a nice general conversation, ask them how they're doing, then lead into the ice machine. And then, you know, as they're walking by, checking on you, because the customer genuinely, when you're working on ice machines, you're going to be sitting on your ladder for a while. Okay. Try to stay busy, but even if you're not staying that busy, every time the customer walks by, grab them by the hands and say, you know what, it's really kind of weird. This is what I'm watching. You kind of explain things to them, you know, make them feel like they're getting something for the time you're just sitting on that ladder waiting for the machine to make ice. Okay. Because we all know if we work on the ice machines, it's a waiting game. Okay. What I like to do is take my notepad and write everything down just the whole time. Even though it really doesn't matter, the Hoshizaki ice machines, you're looking at the pressures 5 minutes into the freeze cycle. I continue to write down my pressures the whole time, just taking notes. Okay. It just makes the customer feel more comfortable with the fact that you're just hanging out there. Walk up on the roof, wipe down the outside of the ice machine. You know, while I was waiting for it to make ice, I had my timers running. I went up and I walked to the roof, looked at all their AC equipment, just seeing if there was anything jumping out at me, just trying to stay busy, that kind of stuff. Okay. I really, really appreciate you guys making it to the end of this video. If you guys haven't already, please consider subscribing to the channel. It really does help. If you guys are interested, you guys can support the channel. The easiest way to support the channel is simply watch the videos. Watch the videos all the way through to the end. Leave me some feedback in the comments section. Give me a thumbs up or thumbs down. Let me know if you like it or you don't like it. That's all you got to do. That really does help the channel, okay? There's some monetary ways you guys can support the channel if you're interested too. You can go to my website, hvacrvideos.com, and I have merch available. We have hats, beanies, shirts. We have a restock on shirts coming very soon. We have a new shirt design coming very soon. And we also have zip-up hoodies coming very soon. So stay tuned for that. You also can support the channel via Patreon. You can become a patron. You can support the channel via YouTube channel memberships. There's going to be links to all of this in the show notes of the videos, okay? Also, if you guys are considering any tool purchases, check out TrueTechTools.com. There'll be a link in the show notes. Use my offer code, big picture, one word. You'll save 8% on your order. And if you guys know what you're going to buy, shoot me an email and I can generate an affiliate link, and it actually helps me out a little bit more. So yeah, that's it. Remember, I do live streams Monday evenings, 5 p.m. Pacific on YouTube. And then I also go live on the HVAC Overtime YouTube channel Friday evenings about 6:05 p.m. West Coast time with my buddies. And we kind of just talk about whatever happened during the week. So really appreciate you guys, and we will catch you on the next one.